I get it, you've probably seen a handful of sleek, black boxes on a tech blog promising unlimited AI horsepower, and you're left wondering whether the hype actually translates to anything useful on your desk. The frustration hits hardest when you finally unbox a mini workstation that looks like a high-end router, only to discover that the software feels clunky. The heat makes the room feel like a sauna. Or you can't actually plug the peripherals you need without a dozen adapters. That's why I'm doing this deep dive before you decide to spend a chunk of your budget on a machine that could end up gathering dust. Link is in the description if you want to check the product details on Amazon. The Acer Veriton AI Mini Workstation GN100 UD11 is positioned squarely in the niche of on-premises AI development boxes. It's not a consumer gaming PC, it's a purpose-built server that ships with NVIDIA's GB10 Grace Blackwell Superchip, a 20-core ARM CPU paired directly with a powerful GPU on the same die. The idea is that you get a single piece of silicon that eliminates the traditional CPU-to-GPU bandwidth bottleneck. For anyone who's been tripping over data transfer limits in TensorFlow or PyTorch, that sounds like a game changer. But the real question is, does that architecture actually simplify the day-to-day workflow for a data scientist, a research lab, or a small startup that wants to keep its models in-house? Let's start with the setup. The unit arrives in a compact metal chassis that weighs just over 5 kilograms, making it easy to slide under a desk or into a rack shelf. Because the whole system is a mini, you'll notice the power supply is external, which means you can keep the chassis cooler and you don't have to worry about a massive internal brick. Plug the power brick in, connect the two 200 gigabits per second ConnectX-7 Ethernet ports, and you're essentially ready to go. The first thing you'll notice is the pre-installed NVIDIA DGX OS. It's a stripped-down Linux distribution that comes with the full NVIDIA AI stack, including the container runtime, optimized libraries, and a web-based interface for monitoring GPU usage. In practice, that OS is a double-edged sword. On the plus side, you get a read-a-torrent environment where the drivers are already tuned for the Grace architecture, so you can spin up a Docker container with a pre-built PyTorch image and start training a model in minutes. For a researcher who doesn't want to spend hours wrestling with driver versions, that's a huge time saver. On the downside, the DGX OS is fairly opinionated. It locks you into NVIDIA's package manager, and some users have reported that getting a non-NVIDIA toolchain, say, a custom CUDA-free inference engine, requires digging into the base Ubuntu layers and can be a bit of a hassle. If you're comfortable with Linux, it's manageable, but if you're looking for a plug-and-play Windows environment, this isn't it. Now, about the performance that the headlines brag about. The Grace Superchip's unified memory architecture means the CPU and GPU share the same 64 gigabytes of high-bandwidth memory without having to copy data across a PCIe bus. In real-world tests I've seen on community forums, people report up to a 30% speedup on large transformer training loops that otherwise would be memory-bound. That's the kind of gain you actually feel when you're iterating on a BERT fine-tune and the training epic finishes noticeably faster. However, the benefit tapers off once you move to models that are compute-heavy but not memory-intensive, such as smaller CNNs for image classification. In those cases, you're essentially paying a premium for a memory advantage you don't fully use. One practical strength that often gets buried under the specs is the thermal solution. Acer uses a high-mass cast metal heatsink with vertical slots that channel air directly out the rear vent. In a typical office environment, the unit runs at around 45 C under sustained load, which is quiet enough that you can keep it on a desk without a fan noise complaint. The downside appears when you try to stack multiple GN100 units side by side for a small cluster. The airflow is primarily rear exhaust, so the units in the middle of a tight rack can see temperatures climb into the low 50s, prompting the fans to spin up louder. If you plan to scale beyond a single box, you'll need to budget for additional rack-mount airflow or consider a dedicated cooling rack. Who should consider buying this machine? If you're a data science team that needs to keep proprietary datasets on premises for compliance reasons, the on-device memory and the fact that the entire stack can run without ever touching the cloud is a solid advantage. The two 200 gigabits per second ConnectX-7 ports also make it easy to daisy-chain another GN100 for distributed training, which is a nice future-proofing feature if your model size is expected to grow. Startups that are building AI-first products and can allocate a few $1,000s to hardware will find the value in the reduced training time and the peace of mind of having full control over their data. Who should skip it? If your workload is primarily inference on already trained models, especially if you're serving them through